So welcome back, guys. And so we are talking about the TestNG framework of which can be used for the Selenium, and we have seen the different annotations of the TestNG, then different parameters available for the @test and annotation, and the meaning of different annotations. Then we have seen @data provider annotation, and we have seen how we can actually perform the data-driven testing using the TestNG framework. Uh, then we have seen the little introduction of the TestNG.xml file. Okay, today we are going to talk about the parallelism present in the TestNG. Okay, so before starting the parallelism, let me tell you something about the parallelism first. Now, what is meant by parallelism? So far we have seen how our project structure looks in the TestNG. Okay, so first we have the suite tag, right? Under suite tag we have different classes tag, sorry, different test tags, and under each test tag there are several classes tags, and under classes tag we have class tags, and maybe under class tags we have methods tag, and so on. So this is the structure of TestNG.xml that we have. But a very beautiful advantage that TestNG gives us is the parallelism. Now, what is meant by parallelism? So right now, so far we have executed our test cases mentioned in the TestNG.xml file using a single thread only. Now, what is meant by single thread? So TestNG creates a single thread to execute your entire TestNG.xml file. Okay. But if we want, we can create multiple threads. Okay, we can create multiple threads, and the threads which we have created will execute our test cases parallelly. Okay, so what is the advantage of having parallelism? So obviously, if there are parallelism, okay, sorry, or multiple threads which are parallelly executing your test cases, then obviously the time taken for execution will be reduced. Okay, let us take an example that I have a stem of some I have some wood in my backyard maybe, and I am alone who is having the axe, and I'm just cutting down the wood for day-to-day purpose, for example. So let's say there is 80 kg of the wood in my backyard, and I want to cut it down into pieces using the axe. So obviously it will take a lot of time for me to execute that task. Okay, the 80 kg of wood I need to obviously cut down or chop down. But let's say my 4 friends have joined me to cut the wood into pieces. Okay, my 4 friends have joined me, so obviously now we are 5 people parallelly chopping up the wood, and that is why the time taken to chop 80 kg of wood will be lesser in this case. Okay, so very simple example it is. So whenever we are seeking to execute our test cases parallelly so that we can reduce the execution time, we can get the result as fast as we can. So obviously we should use parallelism provided by the TestNG. So how parallelism works in the TestNG? So in a simple sense, we can parallelly execute our test methods. Okay, what we can do is, so let me show you parallelism in TestNG. Okay, parallelism in TestNG, that is what we are talking about today. So here what happens is, actually we can execute our test cases, or maybe, so what all we have is, we have one suite tag over here. This is the parent tag of testng.xml. Okay, and under the suite tag we have multiple test tags. Okay, multiple test tags, and this may be one more test tag. Okay, these many test tags we may have, and each test tag may have classes tags. Okay, classes tags. So I'm just trying to write down the structure of TestNG.xml file. That's it. Under this classes tags, we may have class tags. Okay, class tag. So let me close this class over here. That's it. And it may have some name. Let's say ABC is a class. Okay, then we may have one more class under this. Let's say XYZ and so on. So I'm closing this over here. So under this class tag, we may have again methods tag. Okay, under the include and so on, include, run and so on. So these are the tags. So for the sake of time, I'm not writing this. Okay, so this can be our structure of the TestNG.xml file. Okay, now what are all things from this TestNG.xml file that we can run parallelly? Okay, so obviously if you talk about the parallelism, we have several things over here which we can execute parallelly, or we can take a decision that whether we want to execute them parallelly or not. So what are all things present over here which we can execute parallelly? So first thing we have is test. Okay, so we can execute the test parallelly. So if I try to run, let's say this is the test 1, okay, and this is the test 2. These are the two tests I have. So if I want to execute test 1 and test 2 parallelly, then obviously only 2 threads are required to execute them. Okay, only 2 threads are required to execute them. So 2 separate threads will execute this test, okay, and this test. So let's say I have thread T1 and thread T2. So thread T1, okay, so let me draw. So thread T1 will execute this test, okay, thread T1 will execute this test, and thread T2 will execute this test. Okay, now there will not be any interception between T1 thread and T2 thread. Okay, they are going to execute these test cases parallelly, simultaneously. Okay, so when T1 will start execution of this entire test, T2 will start execution of this test simultaneously or parallelly. Okay, now all of the test methods inside this test T1 will be executed by only one thread, and that is T1. So let's say there are 100 test methods inside test 1. Okay, so all of these 100 test methods will be executed by this T1 only. So let's say I have test method T1. Okay, T1 through T100 I have. Okay, so T1 to T100 test cases I have. So T1 will first execute T1. Okay, thread 1 will execute T1 test case first, and then T2, and then T3, and then T4, and then T5, and so on. Okay, till the 100. And T2 will execute whatever test cases are there inside this test tag. Okay, T2 will execute only those test methods. Okay, so parallelly this execution will happen over here, and obviously this will lead to a faster execution speed as well as the reduced time to execute your entire suite. Okay, very simple. But the second thing that we can actually execute parallelly is the classes. Okay, these classes. So let's say I want to execute these classes parallelly. Okay, so if you want to execute these classes parallelly, then obviously here, let me show you that this is one class, and okay, so sorry. Okay, So if you want to execute these classes parallelly, then obviously we can also execute these classes parallelly. So let's say we have created two threads, again T1 and T2 threads we have created to execute the classes parallelly. Okay, so whatever classes are there in the test tag will be executed by T1 and T2 threads. So in our example we have only two classes, but this may be a case that our testng.xml test tag may have 10 classes, may have 100 classes. Now all of these 100 classes or 10 classes will be executed by two separate threads. Okay, two separate threads will execute them. So let's say I have 10 classes over here. So T1 will pick the first one, T2 will pick the second one. Okay, once the T1 has done its execution, T1 will go for the third class to execute. Okay, and once T2 done with the execution of second class, it will continue the execution from the fourth class and so on, or whatever the class coming in the hierarchy next. Okay, so this is how two threads parallelly will execute the test methods. Now uh, test cases present under ABC class will be executed only by T1 thread. Okay, and test cases present in XYZ class will be executed by T2 thread only. Okay, once T1 is done with ABC class test methods, it will shift to T3 class. It will shift to next class which is coming in the hierarchy. Okay, once T2 is finished its execution, it will shift to next class which is coming in the hierarchy. So this is how parallelism acts. So here are two threads which are actually executing your testng.xml. Okay, so first we have seen we can execute the test parallelly. Okay, so one thread, a single thread will execute all the test methods present inside this test tag. Okay, but if we use parallelism for the classes, then single thread will execute the test cases present inside this class. Okay, and next thing comes up is methods. Okay, so whatever test methods we have, we can execute them parallelly by means of methods also. Okay, by means of methods also. So there will be a separate thread for each and every test method present inside our testng.xml. Okay, so whatever test cases present under ABC class and XYZ class, for each and every test method there will be a separate thread. Okay, there will be a separate thread, but do not get confused with this line. Okay, now how many threads we can create, it totally depends on us. Okay, now what is the meaning of it? Let's say I want to create 5 threads, I can create 5 threads. I want to create 10 threads, I can create 10 threads. If I want to create 100 threads, I can create 100 threads. So it is not a compulsion from the TestNG that how many threads you can actually create. Okay, so TestNG gives you a choice to create as many threads as you can. Okay, or as many threads as you want simply. So here let's say I have created only 2 threads. Okay, and I am executing methods in parallel. Okay, so 2 threads will parallelly execute the test cases. Now there will be a separate thread for separate method over here. Okay, so let me quickly summarize these points. So what we have talked about so far. Okay, parallelism in terms of, let's say, tests. So what is the description that we can say? Actually there will be or maybe TestNG will run all the methods present in test tag. Okay, in with same thread means a single thread or same thread will execute the test methods present inside the test tag. So this is what is meant by test parallelism, right? Okay, test parallelism. So only one thread will be assigned to execute one test. Okay, one test tag, entire test tag will be executed by only one thread. Okay, so let's say I have classes parallelism. If I have a classes parallelism here, then TestNG will run all methods present in classes tag with same thread. Okay. So what will happen over here is, if we are using the classes parallelism, then obviously TestNG will run all methods present inside individual classes tags with same thread. So there will be a thread which will be assigned for first classes, then obviously it will execute the first classes only. Once it is done, it will go for the next, and so on. Okay, next we have is methods parallelism. So if we are using the methods parallelism, then TestNG will run all methods present in obviously here or present in, not present in, but all TestNG will run all test methods, actually all test methods with separate thread. Okay, so same thread will be assigned to one method only. So one thread will be restricted to execute only one method over here. So don't get confused over here. Okay, so let me try drawing it in a simple sense. Let's say I have thread T1 here, which is trying to execute something. Okay, this is thread T1 and this is thread T2, let's say. Okay, then let's say this is thread T3 that we have, right? Now let's say we are having test parallelism. So obviously this T1 will look for the test tag, right? This T1 will look for the test tag inside testng.xml. So let's say we have created 3 threads and our testng.xml file is having only one test tag. Then obviously these 2 threads will have nothing to execute, and this T1 will pick this first test tag, and it will execute all the methods present inside this test tag. So this is test parallelism. But let's say we have created 3 threads and we are using the classes parallelism. So this T1 will execute one classes out of it. Okay, so it will search for the test tags, and the test tag, whatever classes we have written, it will pick the first class from that test tag, and it will start executing all the test methods present inside this C1 class. Then this T2 will come in picture because this T1 is busy right now. Okay, so this T2 will come in picture and it will pick the next class from the hierarchy, that is C2 for example, and it will execute the C2 class parallelly. So let's say 10 a.m. this thread has started its execution. So same time 10 a.m. T2 will also start its execution, and this T3 will also start executing C3 class, which is next in the hierarchy maybe, and the same time it will start its execution. Okay, so at 10 a.m. time all 3 threads have started their execution, whereas T1 is executing C1, T2 is executing C2, and T3 is executing C3. Let's say there is one more class, and that is C4. Now this class is not attended by anyone yet. Okay, so once any of this thread may get free, at that time that thread will pick the next class to execute. Okay, now it is not a guarantee that which thread will execute this C4 in that case. Okay, let's say this class 1 is having only 3 test cases, this is having 10 test cases, and this is having 100 test cases. So obviously T3 cannot pick C4, T2 also cannot pick C4, but T1 can pick the C4 after completion of the C1. So this is classes parallelism. In the same sense, what is method parallelism? Let's say we have again 3 threads over here, and T1 thread will pick the first method from the first class, okay, from the first test tag. So it will search for the first test tag, it will jump into it, it will search for the classes tag, it will jump on the first class, and then it will sorry, and then it will go to the first test method present inside that first class, and it will start executing this first test method, that is M1. Then T2 will come in picture, and it will pick the second method from the hierarchy, and then T3 will come in picture, and it will execute the third method in the hierarchy. Okay, the next, once this T1 is done with this method, it will jump on the next method. Then once this T2 is done with its task, it will jump on the next method. Once this T3 is done with its task, then it will jump on the next method. So this is how each and every thread will execute the methods parallelly. Okay, the methods parallelly. Here, remember that all 3 threads are executing the same test tag. Okay, but in test parallelism, separate thread was executing the separate test tag. Okay, and in classes parallelism, separate class was executing the separate separate thread was executing the separate classes. Okay, but what is happening over here is same class test methods may be executed by all of these 3 threads. Okay, same class test methods may be executed by all of these 3 threads. Let's say that class A is having 15 test cases. Okay, T1 picked the first test case, T2 picked the second test case, and T3 picked the third test case. Okay, so from same classes, 3 different threads are executing the test cases. Okay, 3 different threads are executing the test cases. But let's say that some of your test cases are not actually thread safe. Okay, means if you are writing a test case where you have some static variables, you are using some static variable, so obviously your test case is not thread safe in that case, because at a time only one single resource can handle the static resources or static instances or static storage, let's say static variables, we can say. So why? Because static variables have only one copy, and we cannot let multiple threads to access the static copy or static variables. So let's say that your test case doesn't support the parallelism, but here forcefully we are achieving the parallelism. Okay, so we can also skip our test case from this parallel kind of culture. Okay, we can mark our test case to be excluded from the parallel execution. So let's say in future anybody wants to execute the test cases parallelly, but your test case is not thread safe, then obviously you can mark your test case as single threaded. Okay, so we have one attribute, here we have one attribute under @test tag. Okay, under @test tag, and that is single threaded. If you made this attribute as true, then obviously only one thread can access this method parallelly. So there is no chances of executing the same method by multiple threads or maybe something like that. So here you can make your test case thread safe by using this simple parameter present inside the @test tag. Okay. So this is all about the parallelism. So let me show you that how we can actually achieve that. So to achieve the parallelism, we don't have to go in the test cases itself. Okay, we can achieve the parallelism by means of TestNG.xml file that we have. So for the sake of example, let me pick any TestNG.xml file. In the previous session, we also have seen that we can create multiple TestNG files as per our requirement. Okay. So here the TestNG.xml file have been opened up. Okay. Now can you see over here we have only one test tag. So let me zoom this in. Yeah. Okay, perfect. So we have only one test tag under this suite, right? Only one. There should be single suite in the TestNG.xml file. Under this suite we have test tag, and here we have several groups. So we don't want the group, and we have classes over here, right? Under this classes we have class. So let's say I want to execute my test to be parallel. So what I can mention over here in the suite tag itself. So parallelism should be mentioned under suite tag only. Okay, parallel is an parameter. Okay, let me write down the comment over here. Parallel is a parameter for suite tag of TestNG.xml only. Okay, parallel is a parameter for suite tag of TestNG.xml only. Means you cannot use this parameter along with any other tags available, rather than obviously other than suite tag. Okay, so here I have mentioned the parallel tag is equals to threads. So what is meant by that? So I want to execute the tests parallelly. So right now I only have only one test over here. So even if I try to execute them parallelly, I have only one, so it will be executed only once. But if let's say I have one more over here, so obviously now they will start executing parallelly. So let me see what is the name is required. Okay, name is equals to, let's say, and I want to give name as maybe any name I can give. Let's say model B. This is the name that I have given, and under this let me include the same classes. Okay, the same classes I'm including. Now we have two different tests. Two different tests will be executing parallelly over here now. Why? Because parallel parameter of suite tag is set to test, but I haven't mentioned the number of threads. So if I haven't mentioned number of threads, then only one thread will execute them. Okay, but that isn't a parallelism, obviously. Uh, so obviously we have to set the thread count over here, and we can set a thread count by means of thread count parameter of suite tag. Okay, thread count is equals to, let's say, in double quotes, maybe 4 or maybe 2 over here. Now I have created two separate threads which will execute tests parallelly. So two threads will look for the test tags present inside the TestNG.xml, and they will pick the first tag. First thread will pick first tag, second thread will pick second tag, and they will start execution parallelly. So this is how we can achieve the test parallelism over here. But if I want to execute, let's say, classes parallelly, then in front of parallel I should mention classes. That's it. Now two threads will be created. First thread will pick this class, second thread will pick this class. Once this class is executed by T1, this class is executed by T2, they will go and pick the next classes from the next test tag. Okay, now it is not that they will execute only two classes. Okay, but two people will parallelly start executing all of the classes mentioned inside this testng.xml file. So all of the classes, no matter they are in a different test tag or maybe different classes tag, no matter, so they will executed by two separate threads parallelly. Okay, classes. The same way I can write is methods. Okay, now two threads will be created. First thread will pick the test method from class A, okay, and second thread will pick the second method from class A again. Okay, did you getting this point? So this is what the methods parallelism, where two threads will be created. First thread will pick the first test method from the class A, and second thread will pick the second method from class A itself. Okay, once the class A is done, then all of the these both threads will jump onto the class B to execute the test methods present in them. So this is how we can achieve the methods parallelism. Okay, but the next twist comes here is, let's say we have two methods, okay, method m1 and method m2. M1 method resides in class A and M2 method resides in class B. Okay, but M2 method is dependent on M1 method of class A. M2 method is dependent on M1 method of class A, and two separate threads are executing M1 and M2. Okay, in that case, threads will not, okay, disobey the dependency that you have provided. So whatever programmer have provided, uh, that thing will be taken care by the threads. So let's say there are dependent methods, then obviously thread 2 will wait for m1 method to be finished by the thread 1. Okay, so this is what will happen over here. So practically they are not that easy to show you people that how they are going to wait. uh, that is why this is happening a most kind of theory lecture over here. But obviously I can show you the time difference when I execute parallelly and when I don't execute parallelly. Okay, so let me show you that how much time it actually takes to execute. Okay, so that I can obviously show you. It would not be a drastic difference because we have a very small test cases over here and they will not take that much time to execute. That's it. Okay, so two failures are there, 16 test cases have been run. So let me go to the test output folder. We have emailable report over here. Let's open this emailable report and web browser. Yeah, can you see over here, this module A have been executed in 282 milliseconds and module B is executed in 52 milliseconds, and total time needed for execution is 334 seconds, sorry, milliseconds. Now let's try to execute them parallelly. So let me write down parallel is equals to maybe tests. Okay, tests, and thread dash count is equals to 2. So there are two threads which are going to execute tests parallelly. Okay, so let's execute this. That's it. And let me refresh this. So yep, can you see 166 and 161? So equal amount of time is actually observed over here. Where previously 284 milliseconds have been taken to execute the module A, now this time has been reduced and it have come to the 166. But you can see the total time required is still same because we have a very small structure over here, so you wouldn't understand the difference very drastically. So there is not a drastic difference between them, but obviously we can observe the uh, reduction of the time to execute this module A, which was previously 284 or 50 something, 254 something, but right now it is 166. Okay, now let's try to execute classes parallelly. Rather than classes, what we will do is we will try to um, improve the thread count, and let us observe that what is the behavior of it. That's it. Let's refresh this one. So let me show you that what was the previous values. These were the previous values where we had only two threads, 166 and 161. So let's reload this file, and now they are 189 and 132. So this is the count, which may differ obviously each and every time when you execute them. Okay, you can see over here. So as many times I'm executing the same thing, okay, it will give me the different times, because the time taken to execute your test cases totally depends on the system you are using and the performance of the system, internet and everything. Okay, and obviously the test cases complexity. So on those things, the execution time will be dependent. But see, what we have done here is we had only two test tags, right? And we had 5 threads, whereas only 2 threads are executing. Okay, why? Because thread 1 will execute this test tag and thread 2 will execute this test tag, whereas 3 threads will have nothing to execute. Okay, so they just have created. But let us see, let us create 2 threads and let us create classes over here, classes parallelism, and now execute this. So let us observe the before result first. Okay, this is the before result, and now let me execute this one. And that's it, and let's reload this page. So can you see the time is reduced drastically for the classes level? Okay, whereas the test level, the time was very more. Obviously you can now observe the difference. Let me execute it one more time. Let's reload this. Yep, can you see the time is drastically reduced? Previously it was 380 milliseconds, now it is 150 milliseconds. Why? Because there are two different threads which are executing separate classes. Okay, that is where the parallelism comes in picture. Let me execute it one more time. That is quite fast. Yep, can you see the time is reduced drastically, obviously. Okay, now let us increase this thread count, because we have 16 test cases. Can you see total 16 test cases are there? Okay, so let me write down this thread count as maybe 8. Okay, and now execute this one and reload this. Okay, the difference is not that noticeable, but obviously it is reduced. Why? Because we have increased the threads. Yeah, can you see 132 now? From 154 it is 132 now. Let's execute it one more time. Perfect. So it is giving different performances, obviously, but we should observe that the time taken to execute your entire test suite is obviously reduced over here. So let me create 16 different threads, but obviously 16 different threads will not execute simultaneously. Why? Because we have only 4 classes. Understand this, we have only 4 classes, so 4 threads will be engaged and 12 threads will have nothing to execute, so they will be idle in that case. Okay, so let's create 4 threads, each thread for each separate class. Yep, the time is reduced. Now let's make methods as parallel, and now we have 16 test methods, so we are creating only 4 threads over here. First we will create only 4 threads, and then we will increase the thread count. Execute this one, and then let's observe it. Yep, it is reduced drastically. Okay, so let me execute it one more time. Can you see the time is reduced drastically, and you can observe the difference. Previously the time taken to execute was 354 milliseconds, and now it is not going beyond the 180 milliseconds. So that is the very good quality time that we have saved by means of parallelism. So imagine where you have 1,000 test cases to execute. Obviously, they takes a lot of time. Sometimes the tester used to, execute his test suite in the night at 12 p.m. or 11 p.m. maybe, and he used to get the result in the morning. So this is how you can imagine this much time requires to execute your entire suite. So it is recommended to go for the parallelism. Now let's increase the thread count over here. Now from 4, I'm going to make it as 8, and I'm going to observe what happens here. That's it. So this was the previous time. Let's reload it. Yep, it is reduced 165 from 191. Let's run it again. Same thing I'm running again. Let's observe this. Yep, it is reduced. Okay, now increase the thread count one more time. 16 threads I'm going to create. Let's execute this. Perfect. Let's observe the time. Yo, that is reduced. And let's reload this. Can you see the time is reduced from few milliseconds? Obviously you cannot observe the big difference over here, but there is a difference. Okay, there is a difference. That's it. Now let's remove the parallelism. I don't want any kind of parallelism. I want only one thread to execute the entire test suite. Okay, and let's observe the time required to execute. I don't want to mention this over here. (187 milliseconds) without parallelism. So it will increase and increase for each iteration of the execution. Can you see it is 203 milliseconds now? This is 165 again. Whenever your system will perform very good, your processor will respond in a very good manner, then obviously you will observe the less time to execute. Okay, so this is how the time is increasing if we are not using the parallelism. But if we use the parallelism, the time to execute your test cases. Okay, can you see over here 427 milliseconds have been spent to execute everything. Okay, here on the bar we can see the 427 milliseconds. Let us write it one more time and observe the bar. Parallel equal to maybe classes and thread count is equals to 4, and execute this one. Okay, none of the test cases have been failed, I guess. Okay, so that was the time, 365 milliseconds, and that is really less. Methods. And 452 milliseconds. So obviously it is taking less time. So this is what I want to show you people that how the time is actually reducing by means of parallelism over here. So that's it about the parallelism. So if you guys have any questions or doubts, please you can ask now.